LLM APIs, why we are not going for fine tuning very now and then when we start building our own LLMs. So most of us might be aware till today that fine tuning must be very expensive. That could be one of the reasons where we are going for RAG approach, and RAG has become a part of most of our data engineering pipeline. So in our regular pipelines, we build our database pipelines to execute or to refine the queries or to do some joins or here and there some one data source to the another data source. And as per the application or as per the use case, we try to bring up um, the final data source, combined data source that can be utilized for so and so business purpose. But now, when we start looking at RAG pipelines, so RAG has become a very crucial and important role to build a database pipeline. And finally, we have LLM calls at every now and then to recommend the information or to suggest a summary out of it. And then we are trying to get some insights using the LLM to easy our process, even if it is breaking or even some application has some loopholes or bugs. Okay. So we are trying to identify or implement LLMs to identify what exactly happening to easy our job. But it itself, while creating or while developing the pipeline or while designing the pipeline, so whenever we go before to the production, somehow the behavior of LLM and RAG approach is not up to the mark. Maybe it could be, it is not giving a satisfactory result. That's what I can say. But the implementation part and all, we are good. So we design it with a very confident way. And but before moving to production or when we are releasing the application, we are not so confident because of the non-deterministic behavior of LLM. It could be the reason, or there could be some other reason that RAG is not properly or RAG is not able to retrieve the vectors or something very relevant. So that could be the reason. So let us try to understand by breaking down the system, by putting some mind map and breaking down the system. So what could be the reason why actually RAG came into the picture, and what are the reasons? How can we say that the retrieval portion is very relevant, or the response from the LLM when you are combined and sending to the LLM, when the response is when you're seeing the response, you say that, yeah, this response is accurate. So how do you say that? And how confident, what is the metrics that you build, and how confident you are before pushing it to production or before releasing your application? So let's break down the system and see how can we develop this. So at a very initial stage, so we'll try to understand the core limitations. Okay. In these core limitations, the very first approach is you have something foundations of LLM, how these building blocks of LLM got designed, and what are the core limitations of LLM. So we'll try to understand that. In this foundation, you have context management and attention mechanism. Okay. So context management and attention mechanism. Now, So going to context management and attention mechanism is a very important and crucial part when you call an LLM API. But at the same time, there is something before this, you are utilizing RAG approach, okay? Because you're not going for fine tuning, right? So you're going for RAG approach. So there is something RAG pipeline exists. Okay. So if RAG pipeline is exists, then your context management totally depends on how you're retrieving the chunks and sending it to LLM. Then you definitely require a good RAG architecture. Okay. You definitely require a good RAG architecture. Then if you require a good RAG architecture, let me put one up together. Okay. So if you require a good RAG architecture and if you want to design it very correctly and which can retrieve the information properly or which can fit in your pipeline correctly, then how do you say that this is a good architecture? Okay. So you need some validation mechanism. Okay. That means nothing but grounding versus reasoning. Okay. So you need grounding versus reasoning. Now, if you need a good grounding versus reasoning, okay, then you will be telling that, yeah, this my pipeline, whatever the design the pipeline is, very correct. Then you go to production and you see some production challenges. Okay. But this validation mechanism is primarily very important to build the confidence or you build some metrics and you say that, yeah, this is the metrics that we built out of pre-production stage. Okay. So let's come with a normal foundational design, how this design could help us. Okay. A basic pipeline. So basic pipeline for very high level standards. Right. Okay. So in any RAG application, okay, if you take any RAG application, this is my UI portion. And in my application, I have some user login. Okay. My user is logging in here. Okay. So this user has some user interface and he is trying to give some, I'm trying to ask him several things by selecting the drop downs. Okay. So drop down A has some information, drop down B has some information, drop down C, drop down D. Okay. So these drop downs will direct it to particular scenario. Okay. So in each drop down, you have multiple select options. Okay. And if you, it's like, you can just imagine as A has several sections under it, and B has several sections under it, and C has several sections, and D has several sections. So each section you can just click on the drop downs, and as soon as he clicks on the drop down, this will primarily pop him up saying that upload the documents for signature. Upload the documents. Now, as soon as he uploads the documents, these documents, okay, doc 1, doc 2, doc 3, and so on. So these are several documents uploaded in that hierarchy. Okay. Now let's come with the sample header. Okay. He selected A1, B2, C3, D4. Okay. That particular user selected these particular drop downs, and in this sequence, he uploaded the documents. Now, when he uploads the documents, now ideally what should happen? You need a database. Okay. Now, this is your database. Now, in this database, you will have so now in this database, you have doc IDs. Okay. Doc ID is a primary, it's a very important key that get generated whenever you upload a document. Okay. You have some doc ID. Okay. And you have document name. Okay. And you need the status of that particular document. Okay. And then, okay, it is uploaded by that particular user. Okay. And so and so necessary columns. Let us think dot dot dot. Okay. Dot dot dot. So this is one of the table that you have it. What is this table? Let us name this table as document status table. Okay. Now at the same time, you need another table that is nothing but a vector table, which is important for our users. That is vector table. Doc vector table, you have the same document ID, which is present here. Okay. Now you need doc chunk ID, which is getting generated from your ADA model. Okay. As soon as you insert by understanding the chunk strategies, what kind of implementation that you're doing. So that will sequentially generate the chunk ID. And you have doc vector. Okay. And you'll have doc chunk X. Okay. And so on, necessary when it got created and all the necessary fields is it whatever is important. Okay. But these are important. Now this is another table. Okay. Yeah. So now you have two tables for this particular general design. Okay. Standard high level rank design. Okay. Now let's understand the flow. Okay. Before we move on to the next stage, let's understand the flow. So now what primarily happened now, the user has uploaded the documents. Okay. These documents got uploaded. Okay. Now, as soon as the user uploaded the documents, now primarily what it happens, we design two tables. Okay. So this should insert into the database. That's a primary job, right? Okay. Let's understand the flow, saying that you have your database here, DB. Now in this DB, all the documents are getting uploaded, are getting inserted. Okay. Now somewhere you have your LLM call, API call. Okay. Now in this LLM API call, somewhere. Now from this database, what has to go to LLM API call, and the user is also trying to provide some prompt. Okay. From this document, hey, draft me some so and so. This is what he's trying to say in the prompt. Now this prompt has to come to database. Okay. Here is your database, and this prompt should come into the database, do some similarity search from the database to retrieve the chunks or the vector got created and retrieve the similar chunks. Okay. Once the prompt finds some similar chunks. Okay. So this similar chunks, if it is S, okay, this is something called similarity. This is something similarity portion. Okay. So once the prompt has some similar chunks, that will try to retrieve, and this will hit the LLM API. And in the whole UI, you will see user will be able to see some response based on the LLM API response. Now here comes context. Okay, that is going to the LLM API. Now, before context, you have some similarity search, which is trying to retrieve the similar chunks. How it is trying to retrieve the similar chunks based on the prompt, which is trying to convert into embeddings and doing some similarity search on the vector embeddings and trying to retrieve those chunk IDs present here, and it will try to fetch. Now, this is a base fundamental approach. Okay, any application has to come up with such kind of approach. Now, this is clear. Okay. Now, in this process, when you upload the documents, there are two steps which are lying in between these. That is, as soon as you upload the documents, you have to chunk the documents with some chunking strategies, and then you have embeddings, and you will embed the documents. Now, once you try following this approach, like once this kind of processing was implemented in your procedure to insert into the database, and these will create chunk IDs along with the doc vectors. Okay, chunk IDs, doc vector, document vectorization of those chunk text. So this is a very fundamental and important crucial step to fetch the similarity when you implement RAG. Now, what do you mean by similarities? Similarities means you will try to do similarity search on doc vectors and retrieve those chunk text with those chunk IDs. Okay, under the document. Okay. So, okay, this is a regular procedure. We'll slowly deep dive into what exactly happens and how you're going to do some grounding technique and reasoning technique. Okay. But before that, why this approach has come into the picture? Why can't we use the prompt and send the entire document to the LLM? It would be far better, right? Like why we have to follow this design of implementing RAG? What is the basic need of RAG? Okay. Then people come say that, hey, LLM will hallucinate. LLM hallucination means you're sending the whole document and you have your prompt, then it should definitely give the information from those documents, right? Then why it is hallucinating? Even though you are sending using the RAG, okay, RAG is trying to do some similarity search, but the similarity search is still happening from the same documents, right? It's not from the other documents, or it is not going for the open source or something, right? So it is still trying to fetch the similarities from the same document. But is it really bringing down the hallucination, or are you still seeing a different challenges? What are the consequences that you are seeing? So in every approach, you have some challenge of getting or fitting a proper response. That is true. Now, let's understand how actually LLM works. So when we start understanding how LLM works, then we will get to know in a better way how to manage the context, before sending to LLM. So if you hear in couple of a month ago, or maybe in the beginning of 2026, okay, you must be hearing a very buzzword, that is context management. It's a new course after RAG or any agentic approach. context management is a bigger course that has been recently getting more populated. So for every input and output tokens, there is some costing, right? So you you send some input tokens and it generates some output tokens. Depends on the model, the tokens getting generated are very heavy. If you go with Anthropic, it costs a lot. So there are other models, it may not cost that much, but there is some output token costing. Depends on the model performance. Then you mean to say that if you send a very heavy context to LLM API, then the output response will definitely cost you more, right? So definitely you have to manage something to get a proper response. Even the models are not very heavier, right? So now we are slowly getting to understand what actually caused a problem, what not causing a problem. Now, the core problem here is we will it now by default we understood that we are working with some engine. Okay. Either we design the RAG or we have some API that will give the response. Okay. The two things. The design something is in our face, which is in our hands, but the retrieval portion and sending to LLM API is 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 an iterative process where we can achieve a good score, a good accuracy before sending LLM. So when we send an information to LLM, so we need to manage the information that we are sending and we are trying to look for a better response coming from LLM. And this is purely non-deterministic. You really don't know what information if I send, what would be my output response. Or on another way, even though you send the same input, you will see a different response. You can clearly go to chatgpt.com and see, just send an information, just send a prompt, and you see some response, and copy the same prompt, open a new chat window, you see a different response. And you go to some Gemini or another model, Anthropic, another model, you will see totally a different response from three different models, right? But your prompt is same, your expectation is same, but you're observing a different response from different models. Then your endpoint change, then the response change, and this will affect your user also. Then then first let us understand here is something, trick, or there is something that we need to understand why LLM is behaving like this. Okay, when we start LLM behaving like this, the core problem is we want we want we want machine to understand the language, right? Understand the language and answer as per your expectation. Okay, and answer questions or your info. It should process the information like human. This is what at a very first place. This is what our expectation when it comes to using an LLM, large language models. Okay, but what actually it does, but machines do not understand. Okay, the language they predict. Okay, they predict all LLM endpoints or whatever the fine tuning model that is processing. It is purely processing the encoder decoders, and whatever you are sending, it will try to encode and then it try to decode, and it has some attention mechanism. It follows some procedures, and then it gives a output token. Okay, so all it is trying to map the tokens internally and giving you an output token in a fundamental way. Now, getting an output token is a bigger challenge. It should primarily fit as per your expectations. The first token it is getting generated is purely based on the model performance. If it is matching to your expectation, then the following output tokens will literally fall in place. If the very first token which is getting predicted is out of, it is not following in your expectation or it is not following in your boundaries, then the following tokens it is getting predicted are not following in place. So definitely it should align your response. Then we understood that model will predict. Okay, it doesn't understand. Now understanding is lacking here. Okay, you need to make your model understand correctly. Then, okay, before this, there is something called, to make it understand, something called auto-regressive model came into the picture. Okay, so there is something called auto-regression model came into the picture. So before this auto-regression model, what exactly happened? So there are few other models. Before coming to auto-regression, there are few other models which are able to generate response, but those did not set that expectations that what auto-regressive models set today. Okay. So let's understand the key difference what happened earlier and what's happening today. So there is something called ANN. Okay. You must be hearing this ANN, okay, artificial neural networks, and which comes in deep neural networks. Okay. So what is the primary reasons? What is the prime reason of artificial? What is the best thing that ANN does, and what is not the best thing that ANN does not do? Okay. So the core idea of having an ANN is, so the data flow input, okay, it has something basic feed forward neural network where the data flows with the input data points and it has some hidden layers and it gives some output. Okay, so the data flow in such a way you have input and you have some hidden layers and this will generate output. Okay. So any neural network follow the same procedure, but this architecture has a better performance than a machine learning model has. How it is trying to predict all, how it is trying to connect all the data points through the hidden layers. It is fully connected through the hidden layers and each neuron connected to all the neurons in the next layer. So this is how all the data points got mapped, where a foundational machine learning cannot do it. Okay, so the data size is very huge. Then you shift your gears from machine learning to deep learning. And in deep learning, this is a very foundational framework, artificial neural network, where you try to feed into all the hidden layers where each neuron is connected to all the neurons in the next layer. This is how your hidden layers are formed. And as soon as your hidden layer size increases, the data points getting mapping gets increases, and then you have your output results based on the hidden layers. Now, the behavior is something that it assumes as independent data points. Okay, it assumes. What is the drawback? Okay, what's the drawback here? This ANN assumes, okay, each data point as an independent data point. Okay, and it will try to map to all the data points. Okay, which is not required actually. Okay, but this will bring the another problem, that is no sequence awareness. Okay, no sequence awareness. That means it cannot handle any sequence. There is no temporal dependency model. That means it really does not understand which data point falls at what place. So that's a drawback when it comes to ANN. Okay. So we understood ANN. Then there is something called RNN. Okay, there's something called RNN. So now the problem with ANN is there is no sequence awareness. Okay, now at the very first place we need to understand with RNN and solve the problem of no sequence awareness. So the RNN definitely solves the sequence. It can understand, okay, how it is trying to understand, okay. In RNN, the data flow is something like this, okay. The data flow is something else. It is designed, the primary reason for designing RNN is to understand and maintain the memory to generate a proper sequence awareness. Okay. So it is designed for sequential data flow. Okay. With memory. Okay. With memory. So the data flow is something like this. The same network applied repeatedly over the period of time. Okay. That means the the hidden layers or the hidden states, okay, carries the past information. Okay. It carries the past information. Okay. That's the memory management that RNN does. Okay. So the strengths of RNN are it can handle text, it can remember the time series analysis and speech to text. So RNN, you can utilize RNNs. There are few variants in RNN also. That is nothing but LSTM. Okay. LSTM and GR. Okay, LSTM is nothing but long short term memory, and GRUs are nothing but gated recurrent units. Okay, but this RNN is also having some problem. Okay, what are the limitations in RNN? Okay, it has some limitations. What is the limitation? It has something called vanishing or exploding gradients. Okay, that means, okay, this is a terminology. Okay, what is vanishing gradients or exploding gradients? Okay. So this vanishing gradients and exploding gradients, this is a drawback where it is hard to capture long range dependencies. Okay, that means if there is a very big or couple of paragraphs of textual information, it cannot remember the entire tokens present in that textual paragraph. It can remember few of those, but as the hidden states moving forward, it will try to forget. Okay. It will try to forget the information. It can't remember the long range dependency. Okay. So we are able to an extent, we are able to solve the sequential problem that ANN has, but at the same time, it is very slow in training. And due to that slow training, since there is no parallelization, the sequential data it is trying to remember with the past hidden states, it is trying to forget. Okay. So there is long range dependency. It's a problem. Okay. And the other point is the sequential data does slow training. Okay. And no parallelization. Okay. So these are the limitations that RNN has. Then you need a model which will solve long range dependencies and you need some parallelization. Okay. So what is that problem and which solved this problem? That's where transformers came into the picture. So you know that all the LLM APIs, all the LLMs works on the building blocks of transformer architecture, right? So the core idea of transformer architecture is there are two ways that you need to understand and how the transformers got built. Okay. So the very first thing is BERT model, and the other one is GPT model. Okay. So generative pre-train and BERT is bidirectional encoder representative transformers. So there are two mechanisms, and each has its own importance. So bidirectional, it has encoders and decoder architecture, and GPTs has only decoder architecture. Okay. So okay, we need not to deep dive, but we'll understand what problem it solved and how it solved. Okay. So the problem here is we need to make sure our hidden states are remembering the long range dependencies, and also we need some parallelization. So long range dependencies and parallelization, this is a core idea to bring the framework of transformers architecture. And this transformers architecture has something called attention mechanism. Okay, it has something called attention mechanism, and this attention mechanism solved. Okay, the entire architecture was reframed in such a way that it has some self attention layers. It has some self attention layers. Okay, and it has something called multi head attentions layers. Okay, and then it has positional encoding. Okay, and these are the three important one after the other following the steps in the attention mechanism, and this will keep repeating the loop until it find a desired output after using some softmax activation. Okay, so we need not to deep dive, or we need not to understand how it works internally, because these are already being built and you have now several LLM APIs which can be utilized. Okay, but we need to understand to what extent this attention mechanism works, and if you are sending the entire document to the LLM API, will it really pay attention to the entire document with your prompt, or it is having some kind of attention paid to some portion of tokens? So we need to understand that. Okay, but before that, we are trying to understand how the LLMs got the auto regression model, and this auto regression model playing some important role in generating the next token. So we'll try to understand a fundamental part of it, and then we'll see the loopholes. Okay. Now, the behavior is something that this should, based on the above steps, this should process the entire sequence, okay, simultaneously. That means it should have some parallelization. Okay. It should have some parallelization. So that means this will now the weaknesses of RNN are now strength to transformers. How it will capture the long range dependencies. Okay. It will capture the long range dependencies. Now, what is the another strength that it has? It is fast training. Okay. That means it is fully parallelized. Okay. Now, this can scale to a large data set also. Okay. This can scale to large data set. Now, what is the problem if this is a solution? The problem is the limitations here are high cost, high cost. Now you got to know that to utilize transformer architecture or to build your own LLM, this will cost, right? So this will definitely cost because it has some long range dependencies and parallelization instead, and how many multi-head attention mechanisms that you will have in your model, that much of accuracy it can generate. And it's not only multi-head, there is something called mixture of experts, several other um, frameworks that can handle from one input to the another output. So definitely the cost being increased to generate the output tokens. High cost, okay, requires a very large data. Requires large data. Now we understood that this is a transformer. Now transformers are only trying to give a better output. Okay. Then okay. Now this is to an extent this is okay for me. Okay. ANN has some kind of each token, each input is separated. That's where it is unable to have any sequence awareness. And RNN is able to remember the past steps step by step. And transformers, I see everything at once, and it can focus on what exactly matters based on the attention mechanism it has. Now this is purely okay, okay, to an extent. And will it really solve the problem of generating the tokens and that is falling in place? Okay. But there is something called transformers are able to perform and they are able to solve the problems of long range dependencies and parallelization. But the auto-regressive models came into the picture where there is some core problem, that is language is sequential and it is also conditional. That means the conditional came into the picture when each word depends on what came before, which is not solved by transformers. Okay, transformers can only give the output based on the encoders getting connected to the decoders. Okay. So it is able to remember, but adding transformers with auto regression models will purely solve some conditional outputs or conditional tokens that are getting generated using the GPT models right now. Okay. That means each word getting as an output token is purely depend on what came before. Today you predict some word, okay, some word saying that I am learning LLMs. Okay, you say this word. Okay, my word LLM is purely depending on learning. Okay, and then and then I. So similarly, if you want to predict the next token, okay, if you want to predict the next token, which comes next? LLM, I say LLMs and RAG. Okay. I want to predict and RAG. Okay. Or there could be something like this also. Gamma, RAG, and MCP servers. Okay. Or there could be some other word agent also coming into the picture. You really don't know, right? But if you want to predict the sequence of tokens coming one after the other, that is purely depending on the conditional that it has based on your prompt and the weights that your prompt is having. So that's where the auto regression model came into the picture to add to transformers, and the combined model of transformers plus auto regression model will solve your problem and give a better results as an output. Okay. So did you now we got to know that why we have some we want a machine to understand. Okay. We want a machine to understand and answer the questions like human, that is solved by auto regression model based on the conditions it has. Okay. So let's think in such a way that now you got where the auto regression model came into the picture before transformers. Now what exactly the auto regression model does? The auto regression model does, LLMs generate the text one token at a time. So now it got generated token number one. This is purely to generate token number two. The highest weight is given to the token number one. And then you generate token number three, depending on token number one and token number two. Okay. So with your prompt, you are generating token one. Okay. Then token one is giving highest weightage to generate token two, and token one and two combinedly giving weightage to generate token three. Now this keeps going on to generate token n. Now this combined information is trying to bring out a meaningful sense for the user. But the combined information which is trying to make a meaningful sentence to the user is purely depending on each and every token that is getting generated one after the other. Okay, is it clear? So now the problem it is solving, what is the problem that it solved? Okay, earlier with the transformers plus auto regression, earlier the model it could not write long range text where RNN and ANN has. Okay, the outputs are broken. And with only few words, it doesn't generate a meaningful sentence, and there is no coherence. Right? So what auto regression model and combinedly with transformers are getting solved? Okay, you have long range dependencies, long form text generation is being solved, which can generate coherent paragraphs, and now you are able to write a proper explanation summaries with your prompts. Okay, but is it really completely solving here in this auto regression model? Generating a coherent paragraph, is it really solving? Then there should be something else, right? But now you're trying to generate long form of text generations and coherent paragraphs. So is it really solving the entire information? The model which is trying to generate, it will never check the following. What are those? It will never check. Check number one. Okay. It will never verify facts. It will never verify the facts, whether it is true or false. Okay. It will never, at least it will not ask the user a question saying that, are you looking for so and so information, and the information that I have is correct or wrong? It will never ask to the user, is this correct? But it will try to provide you the happy path always. Where whatever the prompt that you are trying to give, it will try to generate some response out of it. By reading the response, you feel very satisfied. Okay, it will try to provide the happy path, though the information is not so correct or irrelevant, or you are unable to get the proper complete information throughout the paragraph, but still you will read the information and you feel some satisfaction out of the information that is provided. But it will never question you, it will never check the facts. But this is some problem, right? At the same time. So the true statement, we can tell something like this. Okay. Since it is not asking you, or it is not verifying itself what are the facts, okay, but it will only check, okay, while generating something, it will only check, okay, what comes next. while generating. It only thinks what comes next, which token comes next, okay, based on the past tokens. So that it will continue the process of generating the coherent paragraphs. That's the goal of autoregressive model. Okay. What is the goal? The goal is to generate, not to give any breaks, not to give any halt. Okay. If it is halting or if it is giving breaks, the model is not going to perform. So you need to perform the model by generating the continuous text until it reaches the end of paragraphs. Okay. So that's a break point. Okay, that's fine. It will always think saying that what comes next. Then, so we can say something like this. The correctness becomes accidental but not guaranteed, right? So whatever it is trying to generate, it is purely accidental. And you have that, yeah, I am questioning LLM, I am giving some prompt to LLM, and it is trying to generate. But since it is not verifying the facts, whatever it is trying to generate, it is purely accidental to bring the next token. Okay. But it doesn't verify the facts. So the correctness becomes accidental. Okay. But whatever it is trying to generate is not guaranteed. Right? It is not guaranteed. Now, in this situation, what is the problem that it could solve? Then it should have something called, after auto-regression model. Now you have a problem to verify the correctness. Then the problem, it has to get solved by probabilistic token prediction. Okay. Probabilistic token prediction. So there is something concept called, okay, this is purely accidental, they say. Okay, it is trying to generate the next token. But how it is trying to generate, then why it is saying that this token number 2 comes after token number 1? How it is trying to say that token number 3 is falling in place after token 1 and token 2? What is the problem? And how can we solve this to align correctly as per the facts or as per the corpus it has? So how can we say that? Okay, there is something called a probabilistic token prediction. Now they thought of saying that, okay, for every token, if the model produces the probabilities, okay, for each token, the highest probability can be the next token. Okay, the highest probability can be the next token. Now you see that token 1 is trying to generate with 40% of probability. Then you have token 2, which is trying to generate somewhere around 35% of probability. Then you have token 3, which is trying to generate with 10% of probability. Okay. Now, in the sample it has taken. Okay. In the sample it has taken. Now, why this problem exists? This problem exists because whatever it is trying to generate with auto-regression model, it is never checking the facts, and there is no correctness in the model. Now you need some correctness. For this, they bought saying that, yeah, the probability of each token getting generated from the sample can solve this problem. And this can also solve the another problem, that is rigidness in the response. Okay, rigidness in the response. Rigidness in the response. Okay. And what are the other problems it has? Repetitive. It can also solve repetitive response. Okay. And it can also solve something like robotic response. Okay. Robotic response. That means you need a human-like response, not a robotic response, because if it is a robotic response, you will always see the same response, right? Repetitive response means for same prompt, you need not to see the same output. You have to see the change in the response. You need to feel like human kind of behavior while looking at the response. There should not be any rigidness. That means if you say something, if you say some keyword, the response should not be the same, whatever the response it is hard coded in the backend. So it should not be like that. It should be some kind of creative insight. Okay, it should have what it should has. It should has creativity. It should has creativity. It should also have some variation. Okay, it should have some variation, and it should sound natural. Okay, it should sound natural. That's where LLMs feel like humans who is responding in the backend. Now, probability says that in the taken sample, if the token number one has 40%, so this will pick as the next token falling in place. Okay. Now, for the same prompt, you always may not select the same sample. You may have different sample. And out of the different sample, you'll see again the probability of token prediction and out of which each token falls in the place. That's where you see the creativity, that's where you see the variation, that's where you see the naturality in the response. Now, is it really solving the problem or it is creating a more problem? How it is creating another problem? So based on our discussion in the very first place, based on our discussion, now you have your documents, you have your prompt, and you are doing some similarity, and you are having some context before you calling the LLM API, and the user is trying to see the response from the LLM API. Okay. Now the prompt that you are trying to give to the endpoint by fetching the similarities and building the context. Okay. Now you see this is the context one that you are calling to LLM. And you, based on the context one, you see response one. Okay. You see response one. Okay. Let's call it as response one. Now, user is not satisfied with this response. Then user is trying to give another prompt. That is nothing but you built another context, that is context 2. Okay. Now, will you see the same response or you see a different response? Okay. You will definitely see a different response, right? Okay. You see a different response. Okay. Response 2. Now, I will copy paste the same context. Okay. I'll copy paste the same context 1 or context 2, anything. Okay. Let me take context 2. For the same context, if I ask LLM endpoint, now this time I will see, will I see a response to? No. I'll see response 3. Okay. Then my user will ask me a question saying that I sent the same prompt, but I see a different response. Since he is not aware of internally what happening in the LLM endpoint, he will see a same response. That is what the problem called as inconsistency. The problem well-known problem using LLMs are inconsistency. That means same prompt will give a different response. Why it is giving a different response? Why this problem got raised? Because every time you will not select the same sample from your corpus. Okay, you will have a different sample getting selected based on the weights the prompts trying to give. So when you select a different sample, then definitely the response would be different. Okay, that's where you need to identify and manage the context before sending to LLM. Okay, that's where prompt versioning came into the picture, catchy database came into the picture, and several other mechanisms that can solve to an extent of inconsistency to provide the good accuracy results or relevant results to the grounding to the user. Okay. So with this, Do you have any questions still here? Just like to take any questions if you have. Any questions? Okay. So the probability to, yeah, go ahead, Randy. Drop downs, what happened? Okay. Looks like, mm, okay, let me repeat at summary level. Okay. So at very summary level, let me write it down here. Okay. So, okay. So at the very first beginning of our session, we are trying to understand, okay, the foundation of LLMs, why we want to understand foundation of LLMs, okay? Then we thought of saying that there is something called in the core component, that is something how the LLMs got built. Okay, what is the mechanism or internal mechanics of building an LLM? Okay, so that is nothing but attention mechanism, and there is some very important role of context management before calling an LLM API, because the foundations of LLMs are purely depending on the attention mechanism. Then we thought that, okay, there is something to build an LLM, it's always costing. Then there is some approach to bring down the hallucination, and at the same time, every data pipeline is now fitted with RAG, okay, having some vectors getting embedded with the information, with the textual information it has. So RAG came into the picture, and how are you saying that RAG will give a good results? So you say that RAG, yeah, RAG will solve this, or RAG will give a proper response by bringing down the hallucination and all the stuff. Then how you are saying it? So you need a proper architecture in designing the RAG. So when you design the proper architecture, that means which is falling in place of your relevancy and near to your grounding response. That means RAG is able to solve the problem without going for LLM or its fine tuning mechanism. Then you need a good RAG architecture. For this, we need to understand a fundamental standard high level RAG architecture, how RAG works, how it gets created with this vectorization and chunking and all the process. So we thought of understanding that. Then there is something called grounding and validation. And how are you validating the response? How are you saying that the grounding is nothing but your actual response, and reasoning is nothing but when your LLM is providing some response, how relevant it is before you sending it to user. So you validate the very closest deviation, or what is the threshold that you are setting for your response. So these are the responses that you are trying to look into for every prompt and observe how your model is behaving with your LLM and RAG in connectivity with RAG framework. So after that, you will see a different kind of production challenges and responses that you see. So definitely there is something, at every stage you will be observing some importance, and every stage is very crucial. So before directly jumping onto the validation mechanism and production challenges and RAG architecture, you definitely need to understand the fundamental steps, how a LLM works and what are the mechanics it has, and why we are trying to manage the context before sending to LLM. Okay. So for this, initially to begin with, we thought of understanding the high level standard RAG pipeline. So for this user, you have some user logging in. Okay. You have your documents and you have your several drop downs in your application, and you select some drop downs A1, B2, C3, and D4. and you upload the documents. This particular user uploaded the documents with so and so doc ID with the document name, and the status is nothing but the documents got processed or not after uploaded. So this is a table that is trying to define the status of the document. And this is a table that is trying to create the vectors of the document that it got uploaded. So now, before managing the context or before sending the LLM the information, you need to retrieve the proper chunked information based on the vectors and from those documents which are relevant to your user prompt. Now, what happens? User will try to provide a prompt, and this prompt will try to fetch the similarities. And before fetching the similarities, your data pipeline processes to insert the chunks and embeddings for those documents into the DB. And then you have your prompt. It will try to fetch the similarities from the database, vector DB. And you have your context, which is going to call LLM with your context. And you see response 1, response 2, response 3. Okay. So though I send same prompt, it will try to give a different response, which will make the user saying that if prompt A is giving response A, same prompt A should give same response, is what user feel like. But if it is trying to give a different response, that means it is trying to hallucinate or it has some inconsistency, right? So inconsistency is a bigger problem. Now, before understanding the inconsistency and saying that this is a bigger problem, let's understand the mechanics, how it works. So usually user intention is to want to understand the language and answer the questions based on understanding the situation, and it should be like human kind of response. But we know that as an AI engineer or LLM engineers, so we know that these LLMs predict the response, predict the output tokens based on the input tokens. Then we came to know that how RNN works, how ANN works, how RNN works, and how can um, this problem got raised till today with inconsistency, and what is the actual blocker of inconsistency. So we understood ANN, and ANN has some, it doesn't have the sequence of awareness. So RNN solved how can remember the past sequence, and what are the other problems in remembering the past sequence. And there are two problems in RNN saying that it cannot remember the long range dependencies. At the same time, there is no parallelization. And transformers are the building blocks of LLM architecture, and the transformers were able to solve the long range dependencies, and these are very fast, and it can also scale to the large data sets, and it has some parallel mechanism where attention mechanism can only pay
Hey,
to
Abhi,
some portion of the, yeah.
can we
Is
give,
somebody speaking?
yeah, can we give like 3 to 5 minutes water break so that, and then we continue?
Yeah, sure, sir.
Yeah, please, now it is 11:21, right? Please join by after 5 minutes. Maybe you can just take small water break and come back. I mean, I think you can take 10 minutes break. We after water break, we take 5 minutes for just like small introduction about company, and then you can take. Okay.
Okay, sir.
Yeah.
Yeah.
Please have a small break, water break. Thank you. Yeah, we gave like 5 minutes break, so that's why you don't hear anything. I think someone is asking. Yeah, so one reminder, so please check your emails because we are sending a different link every day due to technical reason. I'm thinking I can, set up recurrence meeting next week onwards, but at least today and tomorrow it's a separate, webinar links. So tomorrow, please check your email and join. Yeah, if you're looking for one-to-one discussion or career switch or looking for a long-term training with career guidance, please fill our enrollment form. Can someone ping our enrollment form? Yeah, recordings available in YouTube. Please check. Please check YouTube live classes, or we can request our support team. They can help you. One-to-one discussion. Please fill that form. I just sent you. Also, we'll be going over the complete projects, what we teach as part of in our classes, and the projects designed in our GitHub. There are 30 projects we designed in GitHub, level 1, level 2, level 3. Those things probably will be discussed in next 2-3 minutes, and then Abhinav will follow the remaining class. Approve, maybe you can share the screen and proceed.
Yeah, sure.
Mhm.
Yeah, so thank you all for joining the day 3 of our boot camps. So please try to fill up the enrollment form. We'll try to reach out to you offline. So once you like enroll, we'll have the access to all the GitHub repos and also the coursework what we teach in our 14 weeks course plan. So this is our KKR Gen AI GitHub, and we have designed around 30 projects with the level 1 projects consisting of 10 projects. So we have been like discussing this about since last week in the two different boot camp sessions. But for those who have joined recently, so it will be helpful for them for the information. So these are the 10 beginner level project that we have designed, and where you can practice projects and start adding this for your portfolios or LinkedIn's or GitHub, so that you can have the hands-on on the AI projects. So these projects are completely for the people who have come from the different backgrounds, for who want to explore more on the projects with the different domains and different tech stack. And we have given complete end-to-end step-by-step implementation guidance in this particular GitHub repo. So you can just go through everything once you have filled out the enrollment form, and will give the access to everyone. So in the particular first project, beginner level one projects, we have 10 projects designed for for the different industries, for healthcare, finance, e-commerce, legal, and also with the two universal projects, where you'll be getting exposure to OpenAI, Streamlit, and also like how to use Notion, and also like different tech stacks that you have. So these are the like the project descriptions that you have. Everything is clearly mentioned under each and every project. Once you go through everything, you can implement on your own, or will give the guidance from our team, where you can just like start implementing them with our guidance. So in the level one projects, you will be exploring and gaining knowledge about prompt engineering, multi-model AI, working with different scenarios, and also with API integrations, and with the front end, back end, and also with the testing part. So this will be helpful for the people who come from different background, like who doesn't have any like non any technical knowledge, so they can start working on this level one projects. So everything is mentioned clearly with the technology stack, and everything is given to you. And for each project, we have designed the system architecture with the business problem statement, with the project objective, with the system architecture, and also what are the tech stack that you are going to use for that particular project, and the folder structure and the setup, and with the step-by-step implementation guidance. Everything is mentioned clearly, so you can start exploring and implementing these projects on your own. So if you have any roadblocks, or if you want any guidance from our team, definitely we'll help you out in implementing these projects, and this will be helpful for your interview purpose as well. So in the same way, we have designed level two projects as well. So this is level one with the 10 projects that we have, and level two, which is the intermediate level, we have almost 10 projects in the level two as well. So this will cover around like different RAG pipelines, vector databases, agentic workflows, automation with N8N, and also with the different architectures. This will be helpful for those who have already completed level one, and they can also for the people who have the foundation level experience from AI engineering or data science background. So even this is given with the complete descriptions, and also complete implementation guide, where you can just explore and start implementing them. In the same way, we have also the level three projects, which are advanced projects. So you can, once you complete level one and level two, so you can come to level three, where you will be working on multi-agent orchestration, and also fine-tuning methods, real-time streaming with the land graph stateful agents, and how you can deploy on the cloud. And also it will like cover complete full stack AI from front end to back end and everything. So this will be helpful for your portfolio, and also help you for the preparation for the interviews, or also for the LinkedIn's, and to add some benefit to your profile as well. Even this has complete technology stack with the LLMs, agent frameworks, fine tuning vector databases, cloud platforms, and also like the external APIs, databases will be covered in the level 2, level 3 advanced level projects. So we also have 10 more universal projects which will cover entirely different domains universally with the business use cases. So once you have the access, you can explore and do these projects with our guidance. And this is our course plan. Like we have 14-week course plan that we are having, like with the foundations, we start with the foundations, and we have machine learning concepts, deep learning, NLP, and then we go on to generative AI with the agents, LLM fine tuning, agentic AI frameworks, and how you can deploy on the cloud, GCP or Vertex AI or AWS. We have some of the no code tools, and we have some of the no code AI classes for the product managers, project managers, and business analysts, where we teach completely on Notion AI, ClickUp AI, and also with N8N automations, how you can build applications with Base 44 and also with the Lovable. So definitely this 14 weeks course plan will help you out with the foundation to the intermediate level and also with the advanced level projects. So try to, this is our YouTube channel, try to subscribe them for the recordings. So for the day 1 and day 2 recordings, we have already uploaded here in the YouTube. So if you miss any classes, you can refer here. And also like for the rest of the bootcamp classes, we will be uploading them here in the YouTube. And also we have some of the playlist and the previous class recordings where you can get all the information through our YouTube channel. So try to follow our YouTube channel, and also we have our LinkedIn channel where you'll get all the information regarding the boot camp and also the upcoming classes, as well as all the updates in our LinkedIn page. So try to follow this LinkedIn page. Definitely, you'll get all the informative stuff from here. And also, our team has been sending the enrollment form in chat. Try to fill out them. So definitely, we'll try to reach out to you. Yeah, and yeah, thank you. And Abhinav, you can take over the class.
Thank you, Apurv. Just checking Abhinav is back or not.
Yeah, I'm back.
Thank you. Thank you. Yeah, proceed. Yeah.
Yeah. So I'm open for the doubt sessions. So any questions or any kind of information. Yeah. Any doubt sessions? Okay, let me finish up the saying that why did we come up with the transformers? And so transformers are able to solve the parallelism that it has along with the long range dependencies, which are able to solve for the large data sets. That means whenever you fine tune an LLM, so fine tuning play when you fine tune an LLM, you will have lot of multi-head attention mechanisms, which will be a bit coster to build the training set and to train the data to build your own LLMs. And if it is costing very high, okay, so once your model is ready, you can use that model to make sure that is able to understand your context that is passing through the LLM. So that's where you have all your open source models, LLM models, which has certain set of billion parameters which got trained on that particular huge corpus. And now your model is ready and it can perform better, not to bring down, it cannot bring down the hallucination, but it can solve to an extent. So if it is solving to an extent, then at a very high level, your transformers are playing an important role to pay attention to your context that is passing through the LLM. Then the transformers with a combination of auto regression model will try to generate the coherent paragraphs with long range text generation. That's where you are able to solve the text generation, which is very coherent. Now, your your model is able to generate which fits to your use case or to your situation. It is able to generate the text continuously without any breaks. Then what is the another problem that is trying to bring up? It will never check the facts and it will never ask the user, is it correct? Whatever the problem is trying to get generated. So we, as a human, if a user is trying to question anybody, so we will re-verify whether it is right or wrong. But as a model, it doesn't verify or cross questions whether it is trying to move as per the direction or user expectation. So you need some probabilistic token prediction, which is present inside that will try to align the tokens as per the response. But this is solving something which is having creativity, variation, and natural tone present inside. Okay. And this creativity, natural variation is also creating another problem that is nothing but inconsistency. So for same prompt, you'll see a different response, which may fit to the user expectation or which may not fit to the user expectation. Or another way, I can say that which might be relevant to your response, expected response, or which may not be relevant or accurate to the relevant response. So we should bring or align down the response that should fit to your grounding. That's where the validation frameworks comes into the picture. And you can't directly jump onto the validation framework, right? Before this, you need to at least see some manual reviews, do some manual reviews to look at a proper response. So grounding and reasoning are nothing but grounding is something that your actual response that you're looking for. Reasoning is nothing but after LLM trying to provide you the response, what kind of response that you are looking at it and how close it to your ground, to your actual response. So that's where you will see the difference between grounding and reasoning. And you'll get some threshold. If it is 95% matching, then that's fine, or 85% matching, then that is fine. Because all the LLMs are non-deterministic in nature. They are not deterministic in nature. Non-deterministic means it has some variation, creativity, and natural tone for every prompt. And deterministic means it has some rigidness, repetitive, and robotic response. That means you will always see the same response when it is deterministic. Since LLMs are non-deterministic, you will never have the correct response, and you will always see the 10% to 15% deviation from your grounding. So this is the key problem that we know it, and we'll try to. That's where the validation framework came into the picture, and we'll try to observe the validation frameworks also. So with this, I just wanted to stop and open for doubt sessions. Any kind of questions that you have, feel free to ask me, and yeah, we can take it ahead from there.
Yeah, please raise your hands for any questions so that we can unmute. Yeah, based on the order, we can unmute one by one. Approve, maybe you can start unmute one by one.
Yeah. Abdul, you can go ahead.
Sir, good morning. Thank you so much for your time and explanation. I'm basically I'm SAP consultant. I have more than lot of experience. So with AI, I have general basic question. The jobs will increase or decrease. I know we are companies are trying to do the automation, all those things. So because when we look at the RAG models, all those things, one has the problem, another is solving, and another is the problem, another one is solving, right? So what is your anti prediction with the industry with this AI?
Okay. So something, for example, definitely there will be an increase in a job, new jobs that could come. Okay. Who can understand or who can validate the frameworks and who can now, if you look at my lecture, okay, from the beginning, okay, there are
Yeah.
several problems which are being raised. Okay. You can't
Yes.
directly go to the production unless you validate the frameworks, validate the
Right.
responses, and
Right.
you need that continuity of user satisfaction, right?
Right.
So definitely an application being built on AI, if somebody is trying to get into an AI position, okay, definitely there is a lot of scope to join in. Okay. On the other
Mm-hmm.
direction, now what kind of jobs can be uh, very edgy? Okay.
Right.
So that means something that can be automated. Okay. To achieve that automation correctly, you might take some time. For
Right.
example, there is a team who works on manual reviews, or there is a team who is trying to uh, take some like for example take some information from the emails or take some information from the user feedback, okay,
Mm-hmm.
and try to insert or try to update it somewhere, okay,
Right. Right.
uh, okay, to pass the information or to come to a conclusion, okay. Now
Right.
these kind of informations can be automated, right, at the same time.
Right. Right.
But now if it is automating, someone has to review.
Right. Okay.
But today, if I'm automating and I able to generate some summary as per my knowledge, okay, as per
Mm-hmm.
my knowledge, it is only sticking for my conclusion.
Right.
Now, as Abdul is reviewing, for example,
Right.
if you are reviewing, now your thought is different on that particular opinion. My
Right.
thought is different,
Right.
okay, and according to organization, it would be different again. Okay.
Right.
Now, for example, now you are listening to my lecture. Okay.
Right.
Now your opinion is different. If
Mm-hmm.
I go with all the attendees who are attending this session, each person has different opinion.
Right.
Okay.
Okay.
But
Yes.
the owner of this organization should have a neutral opinion from every user.
Right.
Okay. Now,
Right.
what fits to him? You agree with my statement?
Yes. Yes.
Now, my opinion and your opinion doesn't fit here, but your review on the conclusion will fit to the organization.
Okay.
Now, what can be automated? What needs to be done? For example, if I have to automate the process, now I can take the feedbacks from all the attendees who are attending the session and I can
Mm.
generate a conclusion out of it. What is the best step or action item that I can do out of this meeting? Okay.
Yes.
And what is a loophole in my meeting? How can I cover up in my coming meetings? Okay.
Right.
Now, this
Right.
is the summary that I can automate. Okay.
Right. Right.
Now how it is correctly fitting, you need some manual review, right?
Right.
Okay. The owner of organization may not like that review, but you need some other person who can really understand uh, how the pipeline is designed to automate the process. That means there is some other loopholes that we need to correct it. So that's
Right.
where the jobs come into the picture. You need to understand how LLM works and all. So jobs are always been there in the industry.
Thank you
Now,
so much.
this automation who is doing manually inserting here and there, okay? Now these jobs are in risk because as a AI engineer, we are automating it completely.
Right.
Okay, you need someone who can act intellectually understanding the LLMs.
Okay.
So that is what industry is looking for now.
Okay. Thank
So
you so much.
industry is looking for new problem solvers. Yeah.
No problem, sir. Okay. Thank you, sir. I really appreciate it. Thank you.
Yeah.
Next, Satish, you can go ahead.
Yeah. Hi. Uh, Basically, I have a question regarding regarding the LLMs. So, consider I am an infrastructure engineer who is trying to build something from build my own LLM internally, and then I'm trying to use cloud for getting some information or anything from the database or anything. So, is lot of people, my whole question is, from your experience, how people deploy their LLMs? Are they put LLMs internally in the cloud, or they use LLM differently? Because the whole point is, if they call something for building a small file or building a AWS resource or Google resource or anything, will the call goes to cloud first and then LLM, or the people try to call LLM first and LLM calls the cloud? How this whole architecture goes in from? I'm just curious about it because because of the thing. That's my question. You understand, right? What I'm trying to check.
So, for example, it's a very small thing. Okay, there might be some confusion how it's happening. So let's understand like this. So you have your LLMs, right? You have your LLM API. Okay. So think LLM API as your normal API that whenever you build an application. Okay. So whenever you call an API, if it is hosted on cloud, okay, wherever the hosted platform is, it might be an on-premise, it may be an cloud service. So you call the API and that got hosted somewhere. Now, for example, let us think, as per your case, it was hosted in cloud service. Now, there is some service provider who is providing that API. It might be an Azure service provider or GCP service provider or AWS service provider. Okay. Now they hosted the endpoint on their servers, which is internally calling the enterprise servers, which you need not to take care. But the API got hosted in your Azure service. That means your endpoint is primarily calling from Azure service. If it is hosted in your GCP service, it is calling from GCP service. Now, your application is calling that endpoint that will directly call your cloud service endpoint only. Did you get, or is it confusing?
Yeah, no. It's good. It's good. Yeah, I got it.
Yeah.
I got it. So it's like a generic API itself. It's not something new that this gave is. That's what you are trying to say, right?
Yeah, it's a single endpoint. The regular endpoint that you see, it's the same kind of endpoint. That's it.
Okay,
There is
got it.
nothing different.
Okay. One more question is just for so when you do that transformers and transformers, right, in LLMs, so
Uh-huh.
the main objective of this transformer is to convert or understand the language which it speaks or the context, or generally what it does in a high level.
So transformer architectures are the building blocks of the endpoint that you're talking about. That is LLM endpoint. So if you are aware of machine learning, okay. So machine learning, what you do, you just take a sample data and you train the data and you verify it with your actual data, right? And then you export that model that got trained to a pickle file, okay? So when you export it to a pickle file and now you start using that pickle file on your inference, okay? So similarly, when it comes to LLMs, you train the data which is having some transformers mechanism that is used for training the data, and you observe the inferencing, and if your model is up to the mark, okay, you are able to achieve to an extent greater than 85% or something, then you export it to an endpoint, okay? And that endpoint is being called right now as an OpenAI endpoint or Google Gemini endpoint or Anthropic endpoint, whatever it is. So the transformer mechanism plays a vital role when it comes to training the data. So you can have some multi-head attention mechanisms, which internally calls many attention mechanisms, and you will have mixture of experts. Mixture of experts means those experts works on that particular situation only. So there are few other scenarios where internal agents works. So these all mechanism, one after the other frameworks are used for training the data. So it's a bigger, quite bigger concept. So, but it is only for knowledge purpose at the same time. Okay. Now we are in a situation we need not to think much about how it works unless and until you are a open source contributor, or if you are looking for contributing something or developing something out of which the existing system has. But if you are looking for somewhere to expertise in problem solver, or somewhere you want to outstand in your organization, then the direction should be in a different way. If you want to contribute open source, then this comes under research area, and we can talk more about that. Yeah,
Thank you, Abhinav. Okay, that makes
no
yeah,
worries.
I'm good.
Thank you.
Samashiva, you can go ahead and next.
Yeah, hi. Can you hear me?
Yeah.
Yes. Hi.
Thank you. Yeah. And the session came that ways looks good. And from the like now machine learning to deep learning, you are talking about the ANN, CNN, RNN, LSTM, GIU. That ways looks good. I have a couple of questions here. So actually, like I have in my vector database almost to 3 billion documents are there. So is there any optimization way, means like while retrieving it is taking a little bit longer time. So is there any optimization way can I follow that?
Yeah, there are several optimization ways that you
Uh-huh.
can follow. So you're
Okay.
talking about RAG.
Correct. In RAG, right. In vector database, I'm using the PZ vector and
Okay.
it's very huge DB and it's taking a little bit longer time.
Okay. So there are two things in your similarity. Okay. So
Uh,
you're using Langchain framework similarity or
Lang chain.
Langchain.
Hmm.
So you're going with asynchronous similarity, if I'm
Correct.
correct.
Yes. Correct. Asynchronous.
Asynchronous.
I am using the
Yeah.
keyword search as well as the like cosine similarity.
Come again. You're using.
Keyword search as well as the cosine similarity.
Okay, so there is also something a similarity in the Langchain framework. So you're not going with the default one.
No, I'm not.
Yeah, can you give it a try? Because cosine similarity is out of the framework that Langchain has.
Uh-huh.
Okay, so there is something
What the
called
keyword you
a
said? Can you
similarity.
type here? That's easy.
Sorry, sorry.
Can you type that word or what you said? I can't get that one clearly.
Yeah, so cosine similarity is a hard-coded framework. Okay,
Oh.
that is an open source framework which
Mhm.
is having some natural language processing.
Okay.
So asimilarity is a LangChain framework itself having a similarity, which is asynchronously you fetch all the similar functions, so similar vectors.
Mm-hmm.
So just give it a try with that, and hope that will solve the problem.
Okay.
And
Okay.
what is the embedding size that you are using? Dimension size? Is it text large embedding or Ada model
Initially, I
002?
started using the 768, then I came to 1532.
1532. Okay,
Right.
there is something also other model text embedding large, which is having 3772 some dimensions. So
Mm-hmm.
which is very faster than 002. Okay.
Okay.
So it is all about the performance. You upgrade the versions, that is also comes into the picture.
Hmm.
But First, change the frame function that you are using. Go to a similarity in the LangChain, and then give it a try.
Okay.
Yeah.
Okay. So I want to optimize the little bit towards the LLM process in the sense of retrieval process optimization is there, right? So to build the context. So I'm using the
Uh-huh.
reasoning and some other things also. And can you recommend, is there any like optimization to get the context?
Okay. So optimization. So for example, your prompt is a dynamic prompt or a static prompt?
It's a static one.
It's a static one.
Hmm.
Okay. So static prompt is similarity. What is the chunking strategies that you are using there?
Recursive character I have used.
Okay, recursive character.
Recursive character text structure. Yeah.
Okay. So let's do one thing. Because it is like iterative phase. Okay, it's not directly we can go with that.
Hmm.
It is totally an iterative phase. But
Hmm.
we can do one thing. Can you send me the question to this particular email address? I will send you the document that you can follow.
Makes sense. Makes sense. And last one question, final question I have. So currently my
Yeah.
documents are around like 500 pages, and what I'm doing, like no, because of this context window issues and GPT 5.2 I'm using current model. And
Okay.
in that case, like what I'm trying to do, like 500 pages is getting the almost like 3 billion tokens. So to reduce
Okay.
one, what I'm trying, like now using the PyMU PDF and like no some other Python libraries, I'm
Okay.
to reduce the document size. So that means
Mm-hmm.
like getting the only like pharmacy data throughout the document and using the keyword search and using the heading search, and I'm building
Okay.
content, giving calling the LLM. So now my question
Okay.
is using this agentic process. So without Python process, can I directly use anything? You understand
No,
my
no,
question?
no. Yeah, I understand your question. So
Okay.
you have your document. You need
Hmm.
to fetch the particular section from your document and uh,
Right.
send
Giving to
that
the
particular
LLM, calling the
information to
LLM. Right.
LLM.
Right.
Correct?
Hmm.
So you can go with the agentic process here, okay? But
Hmm.
nothing can bypass the Python framework that you're trying to build, okay? But the way you're using should be different,
Mm-hmm.
okay?
Hmm.
Did you get what I'm saying? So
How
the way, the approach,
what
the
they
flow that you're talking should be different
hmm.
to give the good results. Okay.
Hmm.
Whatever that the try that you're giving makes sense, but the approach still need to be enhanced. So you can go with agentic land graph framework also, but
Hmm.
it has a different workflow. First, I need to understand the current flow that you're talking about. Then we
Sure.
can enhance the flow.
Makes sense. Okay, sure. I think we can connect some other way.
Yeah, sure.
Thank you very much. Thanks for time. Bye.
Thank you. Thank you.
Ranjit, you can go ahead with your question.
Yeah, hi, Abhinav. First of all, thank you for your time. So I recently started learning this AI related stuff. I am working as a UI developer as of now, so I have 14 plus years of experience. But yeah, recently started learning AI courses. So I just wanted to know if I would like to switch to this AI data scientist. So currently, what is the expectation from a data scientist role in the industry, and so how good this as a data scientist for the next couple of years or like next few years, that how data scientists play the role in the market. That
Yeah.
is my
So
question.
yeah, the way you're thinking is truly making sense because now going forward, UI will be a bigger challenge, right?
Yeah.
So someone who is working as a developer to build the screens, so that can be automated. Not only UI, you give a prompt in the backend also it develop the functionalities with the code coverage.
Yes. Yes.
Okay.
Yes.
So everything is now getting automated. Every developer is in a phase where he's in a tough situation because the competitor is not the colleague he's working with. The competitor is is something getting automated using AI, right?
Yes.
Yeah. So now, Ranjit, to your question, instead of you focusing on data science skills or understanding some how to approach the data science or some AI and all the things, okay? So you shift your gears to how to solve a problem using these particular tools. Okay. So think in a direction to solve a problem. For example, even if it is your UI, okay, you might be coming up with the different screens, right? So now you start working with um, some some models, okay, to
Mm-hmm.
build. You might be working with different applications till today. Okay, each application has different problem, right? So now start your thoughts from the problems that you have till now worked with your applications. Okay, now which fits where? Just check with the chatgpt.com. Okay, this is my application and this is a problem statement for my applications. Okay, now
Mm-hmm.
tell me how can I solve using Gen AI? Now tell me how can I solve using machine learning? How can I solve using deep learning or NLP? Now that's where you will know the importance of each and every framework. Okay. Now you will list it down all the frameworks which shows very important for your questions of your problem statements. That's
Okay.
where you will prioritize which one to focus first, which one to focus next. Okay.
Mm-hmm.
Now, after listing down all the frameworks, you'll come to a conclusion. Everything from ML to generative AI, everything is important. Okay.
Mm-hmm.
Now, once you come to that area, then you should begin how to understand ML in a very less time, not to put more time to understand or build the frameworks. Okay. You have
Okay.
to understand the concept of each ML. Now, what is the problem of each concept? What is it solved? And why the another concept came into the picture from ML?
Mm-hmm.
Similarly with the deep learning, similarly with NLP. Okay.
Mm-hmm.
Then you understand the basic concept of these areas. Now start working with generative AI using RAG frameworks. So once you start working with RAG frameworks, the similar questions that whoever is asking till today, you will fall in the same area very soon within 1 or 2 months. That's where you will hold two importance. One is related to your UI experience. At the same time, you know how backend AI works at the same time. So you will be a end-to-end developer at the same time.
Okay.
Does it make sense what I'm saying?
Yeah, it is making sense, but so soon, right? This industry is like right now. What I'm observing is like transitioning. We are in a transitioning phase, right?
Yeah.
From the traditional.
So nothing new, Ranjit. See, whoever is started working from 2024, everybody is in transition phase.
Yeah.
Okay, you can't take that somebody who is working in AI is a complete expert in there. Okay, so even I'm in a transition phase. You believe or don't believe,
Mm-hmm.
today I work with something, then tomorrow some new things comes into the
Yeah, yeah.
picture.
That is what happening. Yeah.
So every person is in a transition phase only. So do not put yourself as an outlier. Okay, you are completely new. Nothing pretty new. It's everything same. So earlier there is mainframes, right? So
Mm-hmm.
somewhere Java came into the picture. Then people started adopting Java. Then Python came into the picture. People started adapting it. Then you have machine learning frameworks. Now, machine learning is things like it is outdated, but it has its own importance, right? So everywhere you have its your own importance. What am I saying is, do not assume yourself as an um, at a stage of transition. Okay,
Okay.
start understanding through problem statements. You will get there soon.
Mm-hmm.
Do not go concept wise. Come with problem statement.
Okay.
Yeah. So you can you can reach out to me or you can check with Ram. Okay. So definitely we can have guidance on your questions
Sure. Yeah. Sure.
one on
I'll reach
one.
out to you. Yeah.
Yeah, thank you.
Thank you.
Yeah, next, Raja Possibility. You can go ahead, Andy.
Yeah, hi. Thank you.
Yeah, hi.
Yeah. I have a very similar question what the previous audience asked. Okay, I'm from UI background, 18 years experience. So the question I want to cover here is, uh, see, already LLMs are built, uh, and their infrastructure is also ready. And now their data centers also they are planning to have massive expansion and fine tuning, right? So to give the services. So now we are in a phase where applications have to use these LLMs for their business needs. So we are in that phase. So LLMs
Yes.
today they are trained with global data sets, right? They are not trained with a corporate or specific company's domain knowledge. They are trained across a generic across the business flows. Correct?
Yeah.
So when you talked about LLMs, every company cannot afford those LLMs to again to start from zero to build for their business, right? They have to use the LLMs which are already provided by cloud or OpenX, everything.
Yeah.
So
Yeah.
so what companies will do today is a validation. They will have to build a validation framework. Should have a governance model uh, to make sure, okay, this LLM will suit my business, so that I can subscribe to this and I can do fine tuning or I can have a collaboration with the service provider so that they can build a customized LLM for me. So what is the trends you are seeing today? Because uh, when in a software world, right? So software world is like this. We have SDLC today. We have manual testing, manual development, and now we have automation development and automation testing, right? So now we are in intelligence mode. So what is the trends which you are looking and seeing in the global market?
Yeah. So one of the trend that you called out saying that every company cannot have their own LLM model. They can have some service provider who is already building on that custom, right? So
Mm,
that is one of the key approach. So before I talk something on LLMs, let me talk about ML models, okay? So in
mm,
ML models, the very beginning era of understanding the data models and coming out of a machine learning model. So everybody thought that okay, something getting trained using some Jupyter notebooks, they might be taking 2 to 3 hours
mm,
to train the data, and then sometimes it might take whole day to train the massive data, and something got failed. Then they used to reiterate the process for 2 to 3 days. To productionize any ML model, they must be taking 1 year.
mm,
Then when GPUs came into the picture, it got cut short to few months
mm,
where deep learning came into the picture.
mm,
Now, instead of training, they are just importing the libraries now. For linear regression, you have some library. Everywhere you have some library. Now
mm,
everything was hosted in the cloud. Okay.
mm,
Now you just give a data, it itself understands with different models and it will generate the output results. Okay.
mm, mm.
Now we are at that stage. If you
Okay.
go with Databricks or any other service provider,
Mm,
it will itself understands and generate the report also for that. Okay.
okay.
Now tomorrow there would be a day where you will import LLM as a library also, right?
Okay.
There
Mm,
would be a chance, definitely, because it's getting trained on huge corpus and every user started using. Okay, so
mm,
there would be a day for sure.
mm,
But what is changing, the trend that could change is earlier we used to work with one team and specific team only for years together. But
mm,
now the change that I am seeing is every individual can be a part of different teams.
mhm,
Okay.
mm,
And a problem solver will play a vital role okay, than compared to a developer who is developing the application, who give the idea, who will uh, drive the architectural flow to solve the problem, and who will bring a new problem in understanding the data that can feed to LLM and talk to different scenarios, and then you solve and bring a business out of it. So development is no longer can be there, okay? But somebody should develop, right? If you understand with a prompt to develop it, then you will play another role at the same time. So it is like a mixture of different areas. Who can be a part of it?
Okay.
Sticking to one area is no more. So that's what I can see the trend. So
Okay.
now I want a, that's what I was also telling to Ranjit at the same time, that focus on problem solving rather than focusing on understanding the concepts. Now understanding the concepts, if not today, tomorrow you will get there. Okay, after 3 to 4 months. Okay, but understanding the problem statement is a bigger challenge, right? So now we have to utilize LLMs and give a problem statement to LLM. This fits to my business. This will generate the revenue to my business. So that is what we need to understand. Yeah.
Okay, one follow-up question. So I'm just talking in terms of developers and also not from the leadership standpoint. I'm talking about a software engineering standpoint. See, in current industry, so the traditional way of your growth, career growth means you will stick to the company, so you will learn a lot of domain knowledge, and you will upscale your skill set on a annual basis or quarterly basis, right? So point
Uh-huh.
is, till today, the experienced candidate in a company means who has more domain knowledge and who is contributing to more than one solution. So he may not be a solution architect, but he will be working with the cross teams because he has
Uh-huh.
domain knowledge. So he can work with the cross teams and he can bring solution to the table. That's where he will be having a growth in the company. But when LLMs and this everything coming to picture with infrastructure where companies are subscribing to these models, right? So there is no point of experience here. There is no parameter like experienced candidate only will get promoted. They'll have career growth in the company because you don't need domain knowledge. Seems like because companies already will try to feed the uh, product or domain knowledge to the LLM internally,
Uh-huh.
and
Uh-huh.
they may ask a mid-level experienced guy who has a little knowledge or who has little experience how to play with this LLM and prompt engineering or how to utilize these libraries. They can also
Uh-huh.
bring a solution, right?
Correct.
Solution has to be
Yeah.
validated at a certain point, but where this experience and domain knowledge plays role, like will it be really helpful?
Understanding. For example, see, LLM does everything. If you imagine that LLM does everything, okay, then someone has to validate, right?
Mm.
As you know you know, at least in your organization, you know how you are under your VP or whatever the hierarchy that you have, okay? They
Yeah.
might be handling to some portion of the organization, right? So
Mm.
at least you are aware of the all the architectures that are
Mm.
interlinked, okay? Maybe till today you may or may not, but that's
Mm.
still fine. But you can
Mm.
feed this information to LLM to give the summary of each area. Okay.
Mm.
Now, now you yourself, as being a part of, though you need some more experience, or if I start as a career today, okay, I
Mm.
might take 10 years to understand everything.
Mm.
But within no longer, if I feed this to LLM, that will give me the information very soon. And
Mm.
to digest that information, I may take 2 to 3 months.
Okay.
Okay.
Mm. Mm.
So my 10 years of experience has cut down to 2 to 3 months, right?
Yes.
Okay. So now I will generate some couple of problem statements out of it. Now I will reach out to the right persons
Mm.
and give these problem statements. Now I will be the initiative of those problem statements.
Mm.
Okay. So now where is the experience falling in place? There is lot of cut down in the experience. There is lot of cut down in understanding, but
Yeah.
the domain knowledge, or you might be having good hold of how your organization works, which
Mm.
I may not be aware because I'm a recent joiner in
Mm.
your organization.
Mm.
Now I will take your help to solve these problems. Then you will also find interesting there.
Mm.
So the domain knowledge is all about how are you understanding the problem statement and how are you relating to your organization. So that is, however, few people or a staff engineer in the organization will definitely help there. Okay, that's where its responsibility is at the same time, right?
Mm.
But
Mm.
now if you see that agent is nothing but who can behave like me if I create an agent,
Mm.
or an agent is nothing but I can, uh, uh, if you heard about Meta, okay,
Mm.
Meta is
Mm.
giving a try, okay, it's Mark Zuckerberg is a CEO, he's
Mm.
giving try by replacing himself at the same time,
Mm.
okay, so by creating an agent, how it behaves exactly like him, okay,
Mm.
it's not about particular Meta or something. Now I can replace myself by creating some prompts who can
Mm.
behave exactly like me. Now, a general staff engineer who fits to that organization, you can design it himself also, right?
Mm. Yes.
Now you feed the problem and ask GPT saying that you are a staff engineer working in so and so organization and you are responsible for so and so. Now you have your problem statement that can solve the problem something. Okay, let us think. Okay. Then you
Mm.
give it to LLM and ask. Okay. Then it will tell that as a staff engineer, you first need to understand so and so, so and so, so and so. It says something. Now you join all the dots with your manual reviews.
Mm.
That's where the domain experts comes into the picture, as per my knowledge. Okay, I might be deviating the question that you are asking, but at the same time, domain knowledge, not whoever working in the industry in the same organization for 20 years also,
Mm.
still he will have the lack of domain in that particular
Mm.
organization because it's a continuous iterative process. Okay,
Yeah.
so we can't fit that domain knowledge very correctly, but you can you can swim faster. Okay, what I
Mm.
can say is you can swim faster by cutting down the years with
Okay.
LLMs. That you can do.
Okay. Thank you.
Yeah. Okay, Rajat. So, is there any questions
Yeah,
or
yeah, we have some. Next, Ramu, you can go ahead.
Hey, hi Abhinav. Thanks for all the information. You
yeah,
were
hi.
trying to help somebody for a RAG critical issue, and finally, at the end of the solution, you are saying that you will send some document which somebody can refer. Can you please post it in the chat? If you don't mind.
Um, oh, right now I do not have. Okay, so as per
Okay.
his use case, I can fetch the information and send it to him. That's why I gave my email address to post the
Okay.
questions.
I can shoot an
Yeah,
email referring the problem.
yeah, yeah.
Okay.
You can.
Thank you.
Yeah, no worries, Ram.
Yeah, Sagar, please go ahead.
Hey, hi. This is Sagar. I'm a cloud architect. So I have
Mm-hmm.
a small question. Maybe you might have already covered it. I just want to understand. Let's say like
Mm-hmm.
an enterprise have aggressively using the LLMs and it is trying to develop some of its automation related projects and AI integrated projects. And
Mm-hmm.
they have already implemented some guardrails also to get the security and other federal issues to
Mm-hmm.
overcome. So will that LLM still get trained with this enterprise data?
Uh, Trained LLM. See, okay. If you are using an endpoint, there is no training getting done there. Okay, unless and until if the service providers are capturing the data coming in. Okay, but the
Mm-hmm.
endpoint that you're using will never get trained. The endpoint that you're using
Okay.
is already gotten trained and it is shared endpoint with the different enterprises.
Okay.
Okay.
Let's say like I have several enterprises. Okay. So each enterprise have their separate in-house LLM developed, and they have been using it, and they are using it to a larger projects. So
Okay.
during that context, if you are saying like LLM is getting trained and better, so how does it know that enterprise level data, and how can it make some frameworks
No,
based on the data?
no. So, okay, LLMs, if different enterprises are developing their own LLMs, okay,
Mhm.
is it your question? You
Yeah,
have five
if they
different
have,
enterprises, and each enterprise has their own LLM.
correct,
Okay, so when you can expose the LLM endpoint when it is already trained and reaching some accuracy.
correct.
Okay, so for example, you take 1 year data and you got trained on 1 year data. Okay, and in the month of Jan 2026, I say that my model is performing better. Okay, and I'm exposing this endpoint in the month of February. Okay,
Mhm.
2026. Now, what is the data that I used for training is 1 year data. That is 2025 year data. Okay.
Correct.
Now, whatever the questions
Mhm.
that I'm asking to my LLM endpoint is not in my data which got trained. Okay. It is all doing some inferencing with the existing endpoint. Now, if I have to train my LLM endpoint, again, I have to capture the data from 2026 January to the latest date till today. My training itself will take couple of days to train and feed the information and build the accuracy. So I will never expose my endpoint until and unless it reaches the accuracy. Okay. So that means
Okay.
this is an iterative process where you can't train continuously on the fly. You cannot do that.
Okay. So you're saying every time it works on a pre-trained data only,
Yeah, it only
correct?
works on the sample data which got trained. That's it.
Okay. So
Continuous
if at
training
all,
is not. Mhm.
yeah. So because if you see in the outside market, there are a lot of external LLMs that are being widely popular, right? So if at
Mhm.
all an LLM is should be having the latest data or some kind of latest features to be added for a developer kind point of view, I'm talking about. Some company is developing a new LLM. So how does it know this enterprise level data? Will there be any sample data that is being projected to them, or do they do their own data sets and they develop on their own?
No, no, no. So we are trying to build a machine. Just imagine like this. Okay. Now you
Mhm.
take a machine, for example of a fridge or AC or some machine. Okay. So you have several competitors who works on same building the same engines. Okay. Okay. The best example is car. You have different brands of cars, right? So some
Okay.
car got a horsepower, some car doesn't have. Some car is best in economic, okay? It gives a good mileage. Some car doesn't give the mileage. Some car gives a best performance. So you have luxury, economic, different areas, right? Now the same brand, you are going with some brand. Why? Because it fits to you. Okay. Now, do
Mhm.
you think that they will look at the other competitor and release the next version in within a month? No, they don't do that. They will observe the
Mhm.
behavior of the competitor and they will try to be the best in the market as per the competitor, as per that particular version. They might take a year time or 2 years time, but they will release a new model. So similarly, there are all LLM endpoints which are already exposed by different service providers. So they will see which is performing better, which is outperforming better. If you say that Anthropic is outperforming better, okay, but it's also costing a lot, right? At the same time, so you will never go with that if it is costing high. Then you will look for other best performing model which is having less cost. then you will go with that. If cost is your constraint there. So there are few things that you will take care, and the service provider also will take care to generate it. They will take time, but at enterprise, they can't do this activity continuously because it is only used for that enterprise and it is costing at the same time. So whatever the business coming, they have to put for LLMs only. So they don't go with that.
Okay. Yeah, I understood. So,
Yeah.
like, as per your knowledge, like, can you suggest something related to the data breach because of the LLMs or the AI related? Like, any
Yeah.
specific tools that can be used?
Yeah. Can you send me an email with your questions? I'll respond in detail with all the stuff.
Oh, okay, sure. The same email ID,
But,
right? You
yeah.
just made. Okay,
Yeah. Yes, it's correct.
sure. Yeah. Thanks, Abhi.
Thank you. Thank you.
Chandra, you can go ahead. I think it's the last question. Chandra, you can go ahead.
Yeah, I'm good. Yeah, I'm good.
Yeah.
Thanks.
Yeah, if you have any questions, please feel free to raise your hands or post them in the chat. Bino will try to answer them. If not, you can feel free to drop off for today. And we have the one more session tomorrow, day 4 at the same time. So please try to join, register and try to join from the from the from the registration link that you'll get through email. I think Abhinav, I think you should be good. If you have any questions in the chat, you can go ahead. Otherwise, you can drop off. Thank you so much for the session.
Yeah. Thank you all. Thanks for
Thank,
joining.
thank you so much.
Yeah, please feel free to complete the enrollment form. And if you have any queries, try to reach out to the mobile number that we have provided in the chat. Our team will try to help you out. So if you have any questions, you can stay back, or otherwise we can just drop off for today.
Sir, I have a question, simple question.
Yeah, Abdul, go ahead.
So which certification is better for AI to enter into AI?
For entire AI, yeah, like so you have the the contact information. So try to just ping over there. We'll try to send them over the chat to you, or else we can discuss offline.
Okay, thanks.
Yeah, thank you. Yeah, I see there are no questions. I think we can drop off for today. Thank you so much, everyone, for attending the session. And try to join the day 4 tomorrow at the same time. The link will be given to email once you register. So, yeah, thank you. And
Thank
thank
you
you,
so
team.
much.